Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is a video on JavaScript template literals, because they're cool. They're again, another one of my favorite features. So basically before template literals existed, and I was working with strings, so let's say I have const hello, which equals hello, and then I have const world, which equals world, and then I wanted the console log hello world, I would have to do this. I would have to do hello plus empty space plus world. Okay, and then that would be called concatenation. So this is referred to as concatenation. It's going to basically smush those strings together. So I hit save. Let's just see that it works. Node testing.js, and see, it works. Hello world. That's fine, but all the plus symbols, it gets old. But once they introduce template literals into JavaScript, you could just do this. I can do backticks. Backticks are not normal quotation marks. So if you're not familiar with what backticks are, they should be in the upper left of your keyboard. They share the same key as the tilde key, which should be right above the tab. So you want to use specifically backticks. And now I could do this. Hello. And then world. Save. Okay, neat. Okay, no testing, and see, it still works. So I'm just plopping the variables in the template literal, which is really cool. And it doesn't have to just be a variable. I could put expressions in there. So I could be like, hello, 2 plus 2. Save. See, hello 4. Okay, I could run Boolean values. Is 2 equal to? That should resolve the true. Hello true. Okay, I could put functions in there. I could do all sorts of fun stuff in that. It's just going to work with whatever I return. So basically, if I were to create a quick function, const temp equals cheese, so it's just going to return cheese. So if I were to just do this, temp, okay, now it should say hello cheese. Cool, because basically this function resolves, returns the string cheese, and that's what ends up going there. And so this gives you a lot of flexibility on what you can do, which is pretty awesome. Okay, it gives you a lot of flexibility what you can do, but there's another cool thing you can do. Okay, you can tag them. Okay, so let's create a func. Let's just say const tag. It could be called anything. Tag equals, okay, we'll say strings, equals console.log strings. Okay, it's because first what it does, and then let's say expression 1, expression 2. Okay, so if I run this, okay, and I console log strings, expression 1, expression 2. The way it works is that to use this function as a tag, I would just put the word tag for my template. You put whatever the function's name is. So what it does is that when you put this function name in front of the literal, it's going to go look for a function of that name and then it's going to break up the string and pass it into that function. First, it passes an array of all the strings, and then it passes each expression as a separate argument after that. So the hello will be passed in as expression 1, the temp will be passed as expression 2, and then here I'll just put like some strings in there just to kind of see what happens. 1, 2, 3. Okay, save. Hello is not defined. Oh yeah, I deleted hello. So, and I deleted temp. So we'll just put cheese Gouda. Okay, so here I'm just plopping strings as an expression, which is kind of a silly thing to do, to interpolate a string into a string, but it'll get my point across. Okay, so you see here, see that first variable here is the array of strings. So it takes the string 1, then it takes the first expression and passes it as a separate argument. Then it takes the next string up until the next expression, passes it as a second thing in the array. Then we see this expression, passes the result of that expression as another argument. And you guys get the point, okay? Now, how would you use that? And you see it returns undefined because I was console logging it, so and that function doesn't return anything. But there's different ways you could use it. You know, you can just be as creative as you want. You can create different syntaxes for things like just trying to think of a good one. Let's see here. Like, let's say we wanted to parse a date, so we'll sit there and say, hey, date parser or something. Date. No, let me think about that for a second. Okay, we'll just say first name, or let's say breakup names, or break names, okay, equals, okay, strings, so we don't care about the expressions, okay. Put that down there for a second. And we'll say that it returns what we'll do is we're going to destructure the string. So it's const last then first equals strings. Okay. And then we return last, well, we will return an object that says first name. We'll just say last and first. First and last. Okay, so that's what that does. So let's say I change this to break names instead. Someone tag it with break names. That's the function is going to run. And instead, I pass this. I pass my name is Merced. Okay, Alex. Okay, that expression ends up breaking it up. It's a silly way to do things. In particular, like there are other situations where you may want to use tags better, but just one way to think about it. Save. And then if I console log, if I run the code, there we go. So first name, last name. Okay, so basically I would sit there and say, hey, if you want to put in someone's name and you want to be returned to you as an object, you would just tag a template literal and put some sort of expression between the last name and first name, and that would do it. I wonder if you could just put in a empty expression. Pretty sure that should still work. Save. Unexpected token. I guess it doesn't want an empty expression, so we'll just put a dash. Well, it has to be some sort of something. Dash. Save. Okay, then I run this, and there we go. Let me just try one more time. I'm gonna ignore ESLint's warnings. I just want to see the error myself. If there is an error. Yep. These can't be back to back. Okie dokie. Okay. So I can even just put true. And that would still do the job. Okay. So, I mean, that's a cool feature where you can kind of create interesting ways to use template literal syntax to do all sorts of interesting ways of breaking down strings to do things. Another really neat use of strings, since I'm here, is the eval function. Okay? The way the eval function works, I've been using this a lot lately. Eval takes a string, it doesn't have to be a template string, but I'll use a template string, and literally parses whatever's in the string as JavaScript. So basically, let's say I did console.log. Well, let's do let's create another function. Let me try to think of a good one. Actually, let's do it this way. Okay, eval. And then we're going to do const cheese equals 5. Okay, so this is just a string. But since I pass it into eval, eval is going to evaluate the string as if it were a JavaScript text. So it should create a variable and assign a cheese, and then I should be able to console log that variable. Okay, cheese. So if hit save, cheese is not defined. Let me think about that for a second. Const cheese eval. That should work. Let me try this. Const cheese equals 5. What if I do the console log in here? Save. Get rid of this console log for a moment. Save. That works. Okay. Cool. Okay, so I'm assuming that there's a scoping issue in here. So since the cheese is running there, so what I could do is I could declare cheese here and then do this. So let's say let cheese equals 4. Okay. And then cheese equals 5. And console.log cheese again. Save. And see, it works both times. Console logs the first time and the second time. And then if I were to switch this around, so we can see that it was 4. Okay, save. See, it's 4 and 5 because first it console logs the cheese, then we do the assignment. But see, it's all in the string, and the string is evaluated as JavaScript. This could be fun for all sorts of really, like I've used this for creating functions that create classes. Okay, in a sense. So you could literally just do something like, you know, class, my class, my class equals this. And what you do is you put this in a function, and then you interpolate the arguments that the user gives you into the class. So that way the class gets defined using fill in the blanks without the user having to type in all this rigmarole that is the class. You already kind of have all the stuff that's going to always be the same. There, they just fill in the blanks by passing in arguments or something. So there's some fun ways you can use it. But yeah, that's a thing. Aside from that, that's I think a good lesson on using like template strings and fun string manipulation, other than like, you know, your normal string functions like to lowercase and whatnot. I'm trying to think if there's any other really fun uses of strings. Another good use of template literals is if you need to force something to become a string. Okay, like before, like every variable has like a toString property, so I could be like toString and turn that into a string. But with template literals, I could just be like this. I could just be cheese, and then it passes the string of 4. Okay. Actually, just to show you that, let me just get rid of that line. Let me do it in here. So I'll put in backticks, cheese. Okay. And see the different color, it's white instead of yellow because that's no longer for the number, that's for the string. You can do this with objects, arrays, anything you just want to turn into a string. You could just use this interpolation strategy to stringify it. Or you could use JSON.stringify, or you could use toString. Any of these things will work. Yeah, so cool. I mean, I could do the same thing with stringify, so let me just show you that, because you already saw toString, you've seen the interpolation method, and the other way I can turn it into a string is I can just do this. Although, this may not work, because I think this might be specifically for objects, but we will give it a shot. I haven't tried this on a primitive before. Yep, still works. Cool. So I'll see you guys later on.